Today we're going to be looking at using matrix multiplication to solve some word problems involving matrices. And we'll take a couple examples out of your textbook and take a look at them. So here is a bunch of data from a textbook problem. The first table right here, the inventory table, tells us what we have in our two different stores. In store 1 we have, well, first of all I should say we're dealing with skateboard sales here. So apparently in skateboard sales we have two types of models, the complete and the super complete model. And we can see that we've got two different stores. And this data table tells us how many of each type of skateboard setup we have in each store. Our second table is the profit table, and it gives us information about costs so we can see how much the revenue, costs, and profit are for each type of skateboard setup. For example, the revenue from a complete setup is $89, the cost of a complete setup is $44, and the profit is $45 on the complete setup, which is just the difference, 89 minus 44. Now the question I'm going to look at to start here, I'm just going to ask the question, what's the cost of all the boards setups that Store 1 currently owns? So to find the cost of everything in Store 1, well, I need to find the cost of the complete boards and the cost of the super complete boards. So I'd take the cost of the complete boards, the number of complete boards times the cost of the complete boards, 14 times 44. So we've got 14 times 44, and to that I would add the product of the number of super complete boards times their cost, so plus 10 times 58. And when I add that together, I'm going to get $1,196. So there, we've answered the question, no matrix multiplication necessary. But when we move on to the next page, I'm going to set these up with matrices and do a little bit of matrix multiplication and see what results, and I will guarantee you that we are going to see this 1196 show up there. And then we'll take a moment to interpret what all of the data in that matrix multiplication means. So here I've transferred all of that data into matrices, and I've left little abbreviations to remind us what the headings were for the data tables. Because it's really important when we look at this matrix multiplication that this C and this S right here match up with this C and this S right here, just as if I were to say, well, that's an extra row in this table and an extra column in this table. Well, when I went to multiply the first row here by the first column here, the C would match up with the C, and the SC would match up with the SC exactly. So that's going to be very important to us. And I'll go ahead and do out the matrix multiplication, ignoring these right here as I go through the matrix multiplication. And we'll see what we get. So here I've written out in one step the calculation that I went through to perform the matrix multiplication, and then down at the bottom we have the result of that matrix multiplication. Now if we look, here is exactly the calculation that I did on the previous screen to find out the total cost of all of the boards at Store 1. And here is that number, 1196, that I got as a result. Now I can actually go through and put headings on here. Now it kind of acts like this C and SC up here canceled out this C and SC here, but every other heading we can just keep there, I'm sorry. So for example, if I look at this number right here, that would just be the total profit if I sold all of the boards at Store 2. Well, and that makes sense looking at the calculation. This piece right here, well, that's the number of the number of complete boards at Store 2 times the profit for complete boards. And if I look at this right here, that's the number of super complete boards times the profit for the super complete boards. I add those two together and I get total profit. So just for one more example, I could look at this right here, and that 1575 would be the total revenue if I sold all of the boards at store 2. So hopefully we're beginning to see how this works. We'll take a look at one more example. So let's take a look at these two tables that I've got here. The table on the left gives the value of 3 different craft products that have been created: wall hangings, clothing, and rugs. And the table on the right tells us how many of each of these types of items each of these people have made. Okay, and the name Devin, that's how they spelled it in the textbook, so I just went with it. So let's look at turning these into matrices. Pretty straightforward. 12, 7, 10. 10 to 1, 5, 5, 7, 3, 7, 7. And I might go ahead and try to multiply this and see what the result would mean. But if I look at multiplying in the order I've got here, I can see that matrix, if I call this matrix A on the left, matrix B on the right, I can't even do the matrix product A times B. So I just went through and I just put little abbreviations to remind us what the headings for these things should be. And it turns out that A times B doesn't work, but if I do the matrix product B times A, that is going to work out. And if I switch the order of these, this row here is exactly going to match up with this column here, which is what I'm looking for to have a meaningful matrix multiplication problem. So the matrix multiplication problem I want to complete, which I'm not going to do here, will look like this. So this multiplication problem will work, and I can see that I'll have HCR here. It's going to match up with HCR here. Those things are sort of going to cancel each other out and give us a meaningful result, which will be a 3x1 matrix that will tell us how much money each person would gain by selling their item of art, or all of their items of art, I should say. So I'm going to leave it there, and I'll give you one problem to try to prepare for class tomorrow. Okay, so here is the problem that I'm going to ask you to prepare for class tomorrow. We've got 2 tables of data. The first table right here identifies a school and then says how many of each type of football score that team made during a season. And the second table identifies the type of score and how many points each one of those scores is worth. And the question that we're trying to get at is how many points did each team score during the season? And the way you're going to approach this is by turning each of these tables into a matrix and determining which order you need to do the matrix multiplication in, and then interpreting your results. So we'll talk about this in class tomorrow. I'll see you then.